Hello there, ladies and gentlemen. Today we're going to look at factoring trinomials that have a leading coefficient. So if you remember previously, all of the trinomials we looked at, that x in front of the x squared was a 1, right? We didn't see anything in front of it. Today we're going to see what happens when we have numbers in front of there. Specifically, we're going to see ones that have a GCF. So basically, we're going to factor them like we did the other day, but we have to first make sure that we take out a GCF before we do that. Okay, let's take a look at what that looks like here. We have 5k cubed or minus 35k squared minus 40k. Now, I look at this and there's two things. Number one, this isn't a quadratic, this is a cubic. Have we factored those before? I don't know how to do that. And number two, I have a number in front here. I didn't have a leading coefficient before. What does that mean? Well, we can factor this no problem. What it really just means is that we have to take out a GCF from this. So the first thing we're going to do is say, all right, what goes into every term? That's going to be 5k. 5k goes into all of these terms. I can take that out. And then I go through and I divide each thing by 5. So I'm going to be left with k squared minus 7k minus 8. And now I have this 5k over here. This right here is now a trinomial that I can factor. This is like the ones we did the other day. So I'm asking myself, what's going to multiply to negative 8 but add to negative 7? And if you remember, we kind of had a trick with the signs. We could list it. We know this is going to be a minus down here. And we know that this one is going to be a plus because this tells us to change what sign we wrote there. So what two numbers will multiply to negative 8 and add to negative 7? It's going to be 8 minus 8 and plus 1. So there is our answer right there. 5k times k minus 8 times k plus 1. Okay, and that's our factoring. We're done. Hey, good for us, all right? Next one we can see here, we have k to the fourth minus 7k cubed minus 30k squared. Again, not a quadratic. How do I factor? Well, let's look for a GCF. In this case, we have a k squared that goes in every term. So we're going to take that k squared out. What's going to be left over? I'm going to have a k squared left over here. Remember, when I divide out a k squared, I'm subtracting the exponents. Same thing here. I'm going to have minus 7k. And then over here, I'm going to have minus 30. Now we have the same thing going on. I'm looking for what's going to multiply to negative 30, but add to negative 7. We know that our signs are going to be minus, because we just bring this down. This tells us to change this, so it's going to be plus over here. So I know one's going to be negative and one's going to be positive. What multiplies to negative 30 and adds to negative 7? I think it's going to be minus 10 and plus 3. And there we go. There's our final answer. Okay, here's another one. Once again, I have a leading coefficient. It's not 1, it's 3. So what do? How do I factor that? Well, we're going to be looking for that GCF. What goes into every term of my trinomial? And in this case, it's just going to be the number 3. So what's left over? N squared plus n minus 12. And now we enter into the next part of my problem, which is, all right, what's going to multiply to negative 12 and add to 1, because remember, if I don't see something here, that means there's secretly a 1 hiding there, okay? I know based off my signs, I'm going to have a plus and a minus. So one's going to be positive, one's going to be negative. And I think that's going to be plus 4 and minus 3. Those will multiply to negative 12 and add to positive 1. There is my answer. Here's another one. Once again, what am I supposed to do here? Well, let's take out a GCF. So I need to find what number goes into 8 and into 162. What's something I can take out? Now, you don't want to just depend on, hey, what if 8 must be, I must check 8, okay? If you're not quite sure what GCF goes into something, as we said before, you can always use your calculator to try, right? Divide out some numbers, some things you know go into both, and see what goes into it. We don't expect you to know what numbers go into 162, but we do expect you to know how to figure that out. So, okay, let's see if 8 goes into 162. Oh, it doesn't. Oh, this one's a little bit weird. All right, what about if I try 4? Does that go in? Oh, that doesn't either. Well, what about 2? Oh, 2 happens to go into both of these. So I can take a 2 out and also a b, and I end up with 4b squared. And when I divide it out of 2, I got minus 81. So you can see we can't just say, oh, it's whatever that leading coefficient is, because sometimes it might not be that, especially with a problem like this, because this we're expected to know because it's a special factor pattern. okay? This factor pattern is actually what's called a difference of squares, meaning what we're going to do is we're going to take this and we're going to factor it by saying, okay, this is going to be 2b plus 4 and 2b minus 4. Okay, if you remember, we talked about factor patterns. Okay, it's got whatever the square root of this is and square root of this is, you add them and you subtract them, and that's our difference of squares. And there we go, we just factored this one fully. Here's another problem here. We have 6w squared plus 72w plus 192. Again, I'm going to start by looking for a GCF. The GCF for this one is going to, in fact, be 6. And again, if you're not sure, okay, I think it might be 6. Let me try 192 divided by 6 and see what I get. Oh, it went in evenly. 72 divided by 6, oh, it went in evenly. That must be it, right? You can kind of figure this out as you go, what numbers go into each of these, okay? We're going to have w squared over here. We're going to have plus 12w, and we're going to have plus 32. It's the one that goes over here. And then I'm going to go ahead and factor this. I'm looking for numbers that multiply to 32 and add to 12. Okay, so again, we know our signs are going to be plus and plus. Okay, so we can think of our factors of 32. The factors of 32, they're going to add to 12, are in fact going to be 8 and 4. Okay, there's multiply 32, and they add to 12. That's exactly what we're looking for, okay? So this is what happens when we have these trinomials that have leading coefficients. We're going to be looking for these GCFs to take out, and then we can factor them just like we did the other day. You'll notice one thing to make sure is to keep this term here that you took out in the beginning. That is still a factor. It needs to be there at the end. I've seen people in the past say, no, I take out a 6, and then the 6 just disappears. That needs to be there. You can see in all of these, in my final answers, look, I have k squared left over. I still have the 5k there. I still have the 3. I still have the 2b. I didn't circle this one, but you can kind of see that first thing we take out, that GCF still needs to be there at the end when you're listing your final answer, okay? Thank you all for watching.